This is Umboich again. I have the revenue and profit assessment to review today. So my graph today looks like this. I chose these numbers because it's much cleaner. So if the phone costs $400, be 90 people buying it. If it costs 580 people buying it, 670 people buying it, 60 people, on, and then at the end I say like if it's $1,100, 10 people would buy it because that's more reasonable. And for my demand, I got a 0.0183x plus 135, and that's because so yes, I plotted my graph as you can see right here, and I got my numbers after I put y1 tilde mx1 plus b, and then I got the m right here, negative 0.1083, and then b is 135. And so yeah. So for my revenue, revenue is demand times x. So I took the demand equation right here and I multiplied it by x, and that will give you 0.01083x squared plus 135x. Okay, and finding the vertex. So the formula for vertex is negative b over 2a, and negative b from the demand equation is negative 135 over 2, and then parenthesis negative 0.1083, which will give you a 623.268. So that's one of the points that I got from the first point for the vertex. And then to get the other, you have to plug in the vertex into the original equation. So to find, so the original equation is negative 0.1083 times the vertex, which we just found, and what we got is a 42,070. So $42,070 and 637 cents. And so this is how my point system would look like, vertex being on the x and the function being on the y. Okay, and then the vertex represents the maximum point of the graph because the graph will be facing down. So how much will the phone cost to maximize profit? It will be $42,070.677. So, yep. Okay, and then for my next set of questions, revenue, like I said before, is the demand price times X. And so this is how the demand original price, and then times it by X, and this is what you got. And then the total cost, which we haven't done yet, is cost is demand but times the cost per phone, and the price that we got for each phone in the equation was $300. And so what we did is we took the demand equation times 300, and this is what it gave us, negative 32.49x plus 40,500. Even. Okay. Looking at the difference between the revenue function and the cost function, this is what we get. This is what we get. The red is the revenue. So if we zoom out, you can see that's the revenue, and it's a parabola because it has an x squared, and then the blue line, which is the cost. And so this is where we get our vertex. And then you can see these 2 points right here is where the cost equation and the revenue line actually meets together down here or combine. So zoom in a little bit closer, this and that. So I think I missed this line. Okay. So the revenue cost. I think we should charge the same price for the maximum revenue. Okay, so now we're gonna get into the profit, and our profit equation is revenue minus cost. And so this is our revenue equation and minus the cost equation, but we have a parenthesis over here because the cost equation has a negative, so you have to make sure that you minusing the whole equation right here. So it would be, if you take 153x minus negative 32.49, which will actually become positive because a negative minus a negative is a positive, it would be 167.49x. And then negative be 40,500. So the whole equation will be negative 0.1083 squared, x squared, got an x over there, 167.49x minus 40,500. And so this is how our final profit equation will look like. So for my graph, I think the maximum profit for that would be negative 40,000, and this is why. No, that's the wrong one. if you look at here, this is our profit equation, and this is the maximum 0, okay, 0 and negative 40.332551. So, and our maximum profit will be 0 because you'll not be making profit selling that much. And then this is the extension project with the Smart TV, and the retail price with 600, you know, the demand will be 8,700 in 1,000. If the price is $800, the demand will be $648,000. If the price is $1,000, 412, 1,200, 202, and to be able to go any further, we would have to find the demand price using this equation, and that would be the demand equation. This is the demand equation right here. And so we plug in the numbers right here, 672 all the way down here, and then we get the mx plus b right here, and we use that for our demand equation. And so we get m is negative 1.23 and b is 1,544.2. And so our demand price is that. And then our revenue is demand times x. So we take this equation and times it by x, and we get negative 1.123x squared plus 1,544.2x. And the cost equation is the demand equation times the cost per price, and what we had earlier was the cost per price is $500, and so we calculated the demand price times $500, so 500, and this is what we got, negative 561.5x plus $772,200. And then we got profit, and profit is revenue minus cost, and this is the revenue equation, this is the cost equation. So what we did is, you know, the x go together, so combine the like terms, and it's 1,544.2 minus negative 561.5x, and what we got was a 2,105.7x plus minus $772,200, and this one the remains the same because it's only x squared and it doesn't change, and there's no like time to it. And so the profit would be, you know, $214,000, $882.33. And the reason why we say that is if you look at the graph, how we have the graph, when we have the profit, we plug in the profit equation, and this is what comes up. And so at the tippy top of it, this is what our equation will be. So